In this section, we are looking at three-dimensional measurement. So we're going to look at some prisms, spheres, cylinders, pyramids. So a little review, working with some units. Recall that there are 1,000 millimeters in a meter. There's 100 centimeters in a meter. There's 1,000 meters in a kilometer. And there are 10 millimeters in a centimeter. So you can use this little chart here for conversions. When you're going from the bigger unit to the smaller unit, you multiply. When you're going this direction, you multiply. When you're going from the smaller unit to the larger unit, you divide by whatever the conversion point is. So if we're going to convert 5.8 centimeters to millimeters, that means we're going from centimeters to millimeters. We're multiplying by 10. We're going this way, so multiply by 10. So this is times 10, which is going to give us 58. And in the next case, we're going from 148 meters to kilometers. So we're going this way, divide, going this way, divide by 1,000. When we divide 148 by 1,000, we get 0.148 kilometers. So that's all you're doing for unit conversions. Just make sure you pick the right directions for multiplication and division, and then the right actual conversion number. Recall with order of operations, brackets, exponents, division, multiplication, addition, and subtraction. You do these pieces in the order they appear. And I believe in your note I removed this middle bar here, so it's not confusing. But it's division, multiplication. So if you see multiplication before division, you do that first. So these happen in the order they appear, and then this pair down here happens in the order they appear. So you can do subtraction before addition. Just a couple really quick examples. If we were to solve A and B here, in the case of A, we have 4 plus 2 squared times 6. So we would do our exponents first. So that's going to be 4 plus 2 times 2 is 4 times 6. And then we will take our multiplication because that appears next. 4 plus 4 times 6 is 24. And then 24 plus 4 is 8. In our second case, B, we have pi times 7 squared minus 2 pi times 3. So again, we start with our anything in the brackets. The numbers in the brackets, there's nothing to do there. They just mean they're going to be multiplied later. So we got our exponents. I'm going to rewrite the pi's along the way here. So that's 3.14. 7 squared is 49. So that's pi times 7 squared. So I'm going to leave 3.14 times the 49. And now in the second part here, we have 2 times 3.14 times 3. Now I'll do my multiplications. 3.14 times 49 is going to get me 153.86. And then my second part, we have negative 2. And we're going to treat that as a negative 2 times 3.14 times 3. And that's going to get negative 18.84. So negative 18.84. So we have our minus there as well. And now we can subtract that from 153.86. And we're going to get 135.02 as our result. So we're just doing everything in order. A lot of times your calculator will do these for you, but if you don't have a scientific calculator or you mistype something, you got to understand how your calculator works because some of them work in different ways. So doing it this way will make sure that you do it in the right order. The next thing here to look at is just a quick review of the Pythagorean Theorem. Remember, when we have a right-angled triangle, that right angle points at the opposite side, which is the hypotenuse, the longest side of the triangle. The other two sides are the legs, the shorter legs. They're A and B. Doesn't matter which one you label A, which one you label B. But we found that the formula for finding a missing value in there in the relationship between A and B and the hypotenuse is that A squared plus B squared equals H squared. So if we find the missing values in these two questions, we have the two types of situations you'll find with Pythagorean theorem. So a squared plus b squared equals h squared. Write out our formula. Fill in the values. That points at the x for our hypotenuse, so that's our hypotenuse there. And then a and b, I'll use 8 and 6. Again, order doesn't matter what a, what b is, as long as you have the shorter legs as a and b. We can square those. 8 squared is 64. 6 squared is 36. That equals x squared. Those add up to 100. And now we got 100 equals x squared. We got to get rid of the x squared. To do that, take the square root of that. That'll get us down to x. But if we do square root over here, that means we got to do a square root on the other side as well. 100, when you take the square root, is 10. 100 is 10 squared, or 10 times 10. And there we have our missing side, 8, 6, and 10. And the next triangle, we have 20 and 16 as the known sides, and x is the missing side. But this time we know that 20 is the hypotenuse. So a squared plus b squared equals h squared. And again, some of the formulas in the books will say c squared. I like h squared because we recognize that it's the hypotenuse. So we recognize the 20 has to go there. And then our a and b, we'll say a is x. Doesn't matter, the order again. B is 16. And now we'll square everything we can. 16 squared is 190, or 256, I believe. 256. If I write 256 down instead of 16 again, would be good. So x squared plus 256 equals 20 squared is 400. Now, this is that situation, some algebra, which is what we're getting into in this unit, or in the next unit, sorry, some algebra. But we have 256 here. We're adding it. So to get rid of it, we need to subtract it. So x squared plus 256 minus 256 equals 400. And we have to subtract it from both sides to keep everything equal. Those will end up canceling each other out. We're left with x squared equals 400 minus 256, which is going to give us 144. We need to take the square root now of both sides to get down to x. And that's going to leave us with 12 as our missing value. So Pythagorean theorem again. Recalling area questions. Recall that the area of a rectangle is the length times the width, or base times the height. It doesn't matter. Again, those terms were arbitrary. The only important ones were radius and diameter. In a triangle, we often say that the formula is half the base times the height, and in a circle, it is pi times the radius squared. So if we do a couple quick examples here, finding the area of our first one is length times width, or base times height, and we have 4 times 6, which is 24 meters squared. In the next one, we have circles, so area equals pi r squared, pi times the radius squared. But we don't have the radius, we have the diameter. The diameter, remember, is twice the radius. The radius is from the midpoint to one side, where the diameter goes to either side. So we have a radius of 2.5, half of that. So area equals 3.14 times 2.5 squared. And 2.5 squared times 3.14 is going to give us an area of 19.625, and this is in centimeters squared. So that's some review: Pythagorean theorem, bed mass, converting units, and area. And we'll get into our prisms and cylinders next.